This is Algebra 1, Lesson 1-3. Today's date is Friday, August 30th, so 8/30. Make sure that you have your name and date on your paper. Before we begin the notes, make sure that you finished your homework on Khan Academy, and make sure that you finish your summary from 1-2. So pause the video now and make sure that you've done those two things. Let's go ahead and see where we're going. So today we're doing 1-3. These are two homework assignments. We have a 3-day weekend, which means when we come back on Tuesday, we'll have a quiz. So it's going to be a quiz on Tuesday, just make sure everyone knows that. Let's see how many people have been updating their unit guides. So if you are one of these people, I am recording this Thursday night at 9:30, so maybe some people need to still update this, but make sure that you're updating your unit guide. Alright, let's jump right back into the notes. So this is kind of a review because we've done equivalent expressions before. Our objective today is to combine like terms with fractions and decimals and to find equivalent expressions. So in example 1, what are the like terms? So you should see that we have a and constant terms. So anything with an a in it, that means that's like terms, and then anything with a constant term like 1.08 or 0.5, those are our constant terms. Let's go ahead and add our variable values. So we do have decimals here. Whenever we add or subtract decimals, we do have to line up the decimal. So I have 1.17. This is kind of like my scratch work on the left hand side here. 1.17 and 2.25. I need to add these two together. Both positive, so 5 plus 7 is 12, carry the 1, and then 2 plus 1 is 3, and then it's going to be 4, and then I carry this decimal down, and then 1 plus 2 is 3, so our answer is 3.42. So we have 3.42a, and then I have to add the negative 1.08 and 0.5, so again, maybe I should move this a little bit off to the side so I have some room over to the left to work. If I do 0.5 and I subtract 1.08, notice I'm lining up the decimal. I can't really do this, so what I'm going to do is I'm going to reverse the problem. I'm going to do 1.08 minus 0.5 or 0.5, and then I'm just going to make the answer negative going the other direction. So this is 0.50, so 8 minus 0 is 8, 0 minus 5, I can't do that, so I borrow from 1, that turns into a 0. This is now 10, 10 minus 5 is 5, so 0.58, and I have to make this negative. So this is going to be negative 0.58, and there is my final answer. Box it. Alright. Example number 2. Now we have fractions. So let's go ahead and find like terms. I have 6/7 m and I have negative 3/4 m. Those are my like terms. I also have positive 3/4 is my constant, negative 1/3 is another constant. So I now somehow need to combine 6/7 m with 3/4 m. So the question now is, what is 6/7 minus 3/4? And in order to add or subtract, I need to have like denominators, so I need to play with this a little bit. I'm going to multiply this fraction by 7 over 7 and the left fraction by 4 over 4. When I do that, it turns into the problem 6 times 4 is 24 over, then 4 times 7 is 28. And that's going to be subtracting 3 times 7 is 21. Again, 4 times 7 is 28. Now that I have like denominators, I can actually subtract these. 24 minus 21 is 3, so 3/28. And of course we were talking about m, so my final answer I'll leave over here in the far right is going to be 3 over 28m. And then I need to do some more scratch work to find what 3/4 minus 1/3 is. So our new problem is, what is 3/4 minus 1/3? again, in order to add or subtract, I need to have like denominators, so I need to play with this a little bit. I'm going to multiply this for the top and bottom numerator and denominator by 3 over 3, and multiply the second fraction by 4 over 4. I'm just kind of choosing the opposite. So if I have 4 here, I need to multiply by 3, and if I have 3 here, I need to multiply by the other one by 4. Alright, that will change our fraction. So 3 times 3 on the top left is going to be 9. Bottom left, 3 times 4 is 12. Subtract, 1 times 4 is 4. Bottom right, 3 times 4 is 12. Right, I have like denominators, which means I can subtract the numerators. I can subtract the tops. 9 minus 4 is 5. The bottom stays the same, 12. And that is my answer for the constants. So I'm going to say this is positive. This is positive 5/12. And there's my final answer. Let's move on to example 3. Example 3 is very similar to example 2. Like, how do I deal with fractions? But this one also has distribution. So the first thing that I'm going to deal with is the distribution, and then I'm going to deal with the subtraction, just following with PEMDAS. So I'm going to distribute this -2, not just this 2, but the -2 into both of these two terms. So how do I do that? Whenever I multiply by -2, I'm really multiplying by -2 over 1. Alright, so I'm going to go ahead and figure out what this right-hand side is, but I'm going to copy down the left-hand side before I forget it. The left-hand side is still 2/5 y. Just copying him down. And then now I have to figure out what's going on here. I'm going to multiply the tops, multiply the bottoms. The top is -2, the top is 1. -2 times 1 is -2. So I'm going to leave the negative here, -2. And then I'm going to multiply the bottoms. 1 times 4 is 4. So this was the first distribution. -2 times 1/4 y is 2/4, and don't forget the y. Okay, now I need to distribute this -2 into the 3/7. Again, the top multiply the numerators. -2 times 3 is -6, so -6. And then we'll multiply the bottoms. 1 times 7 is 7 over 7. Okay, I've successfully distributed the -2. And now I just need to combine like terms. So what are my like terms? These are my variables, and there's only one constant term, and there it is. So I'm going to leave that constant term. There's nothing for it to be combined. So I'm going to come down here and say -6/7. That's still my constant term. I now need to combine these two terms. Again, I can't subtract them unless they have like denominators, so I need to play with it a little bit. I'm going to do some scratch work over here on the right hand side because I'm running out of room. I had 2/5 minus 2/4. I need to have like denominators, so I'm going to multiply the top left by 4, bottom left by 4. I'm just choosing the other denominator, and I'm going to multiply this right fraction by 5/5. 5/5. That turns now into the problem 8. 2 times 4 is 8. Bottom left is 4 times 5 over 20. Subtract 2 times 5 is 10. 4 times 5 is 20. Now I have like denominators. I just have to subtract the numerators. 8 minus 10 is a -2 over 20. And I'm not done yet because I can still simplify this thing. I can simplify by saying this is really divide the top and bottom by 2, and it's going to be -1 over 10. -1 over 10. And that is the coefficient or the number in front of the variable for y. So if I come all the way back over here, the answer here is -1/10, which is that number that I found, y. And there is our final answer for number 3. We're on the back side now. So this is the second homework assignment. Examples 1, 2, and 3 are from the first one. This is the second one now, finding equivalent expressions. So I need to find expressions that are equivalent to t divided by 5 and marking all possible answers that apply. That means I could have 2, 3, or even 4 possible answers. Or maybe it is 1. We'll see. Alright, so t divided by 5. T minus 5 and t divided by 5, that is not the same thing, so it cannot be a. Subtraction and division are separate operations. 1/5 t. Well, this is correct because this is the same thing as t divided by 5. Another way of thinking about it is this is 1/5 times t over 1, because t is the same thing as t over 1. Multiply the tops is equal to t, multiply the bottoms equal to 5, t over 5. So these two are indeed the same. Let's look at part C. T. If I add them all together, that actually gives me 5t. So this is equal to how many t's? I am counting 5 t's, which is close to t over 5. It's just multiplying instead of dividing, so not c. And then d, that is another way of saying t divided by 5, t fifths. So that is indeed correct. So our answers here are B and D. All right, we're almost done. Last example before we can work on the homework. Example number 5, which expressions are equivalent to this thing? And mark all that apply again, so it might have more than one possible answer. Please make sure you pay attention to what Khan Academy says. Sometimes it'll say mark 2, and then you'll know that there's 2 answers. In this case, you don't know how many there are, but you know that it might be more than one. So I'm going to simplify this first one, and then I'm going to have to simplify all of these as well and see what happens. So if I simplify this, let's find like terms. So I see a 6k and a positive 2k. I also see a negative 3h and a positive h. So let's do these k's first. 6k plus 2k is an 8k. I just add the coefficients, add the numbers out front. Then I'm going to subtract, or do this negative 3h plus h. That's going to be a negative 2h. So minus 2h. All right, that is the simplified form of that expression that it gave us. So now I need to see which of these also look like this. Well, immediately I say, oh, 8k minus 2h. Well, that's an answer because that's literally what we just got. 6kh, that does not look right. There's nothing that I can simplify for c. But a and d I both need to distribute. Let's see what we get. So I'm distributing this 2 into the 4k, 2 into the negative h. Let's see, 2 times 4 is 8, so 8k. 2 times negative h is negative 2h. Negative 2h. So that one also is correct. So A and B. Let's check D. 4 times 2k. 4 times 2k. 4 times 2 is 8. So 8k. Oh, looking like it might be it. 4 times this negative h is negative 4h. It was close, but that last part made it so it's not the same. Not equivalent. So our answers are A and B. All right, that's all I have for the notes. Again, the summer you should not be doing in class. You should be going straight to Khan Academy, and be warned that we will have a quiz when we come back to school after the 3-day weekend on Tuesday. I hope you guys all have a good 3-day weekend.